This year, Mars is going to culminate or climb quite high in the sky when it transits. So at 1 a.m. here, you see that Mars is actually going to be nice and high in the sky, about 71 degrees. The last time we were at opposition for Mars back in 2020, Mars was quite a bit lower. It was only 51 degrees when it was culminating or at its highest point. So this year is a good one. And the next few oppositions are happening when Mars's orbit and Earth's orbit are diverging. So Mars will not be quite this close next time round in about 25.5 months. And then so on until we start getting into the point where the orbits are starting to converge again. I think it's in the sort of the 2030s before that happens. So on the 30th, that's the night you want to be looking for the features on the planet. You can also better see the moons of Mars when Mars is at its closest to the Earth, but you do want to wait for times when the moons are farthest from the planet, because the planet's glare will flood the eyepiece with so much light that it'll make seeing the faint satellites harder to see. I did note that Phobos and Deimos should be easier to see. So if I use, say, 11 p.m., I think on November 23rd, so let's go back a couple days here. So you can see that Deimos is decently far from the planet. And then a few nights later, on the 26th, 26th, it's on the other side of the planet. And then 2 nights after that, on the other side of the planet. And then December 3rd and December 8th will be good nights for trying for Deimos. Phobos is tougher. It's tucked in closer to the planet, so that's going to be a harder one to get. Things that you can use to make Mars look better. You can actually use some colored filters if you have any with your system. The light red filter will emphasize the dust clouds, if any. The plain red filter will help to enhance the ice caps and some of the surface features. A violet filter will help show clouds on Mars, if any. Light green, again, helps with the ice caps. And a plain green will help with the caps, clouds, and any dust storms that might show up. Now, there's a really terrific tool. Blake and I have chatted about this tool in the past. And I'm going to bring this up and show you this neat tool. So this is put together by a gentleman, and the website is nightskies.net/skyguide/Mars/Mars HTML. And Samantha can put the link in the chat. When you bring it up, you can see that there are places to put the date and time and universal time, and then ways to increment or decrement the hours and the days from that. So if I were to put in, let's say, December 1st at something like 02 UT, which is 9 p.m. on the November 30th, then you can recalculate it. And this is the side of Mars that you'll see in globe form. And you've got down here an option, a drop-down menu that lets you annotate with labels. So you can actually put labels on these features. And they're actually an alternate view as well, with labels as well. So the main feature you're going to notice most apparently is the Syrtis Major, this sort of dark triangular feature that dominates Mars. And if I sit here and I increase the time by a day, you can see that because Mars's day is a little bit longer than Earth's day, if you go out on the same time of the evening on Earth, on subsequent nights, you'll see that Mars essentially rotates a little bit more on each subsequent day. So you can actually sort of see the same range of features on the same sort of week of observing Mars. Another nice tool you've got is Sky and Telescope has a version of this that actually uses a flat version of Mars. And again, you can dial it in. And one other thing to note here is that you've actually got the ability as well. This one is designed to show Mars with a telescope type orientation, whereas the Sky and Telescope one actually lets you select whether you want direct, inverted, or mirrored, depending on the type of telescope you've got. So those are some neat things you can look for. as well. We want to watch out for on the evenings of December 2nd. Let me just bring up my, okay, flip this back around. Here we go. So over the course of the next number of days, Mars is traveling west, as I mentioned, and on the nights of around December 2nd to 4th, so 2, 3, or 4, it's actually going to be passing this big open star cluster, NGC 1746. So that might be a neat thing to see. The field of view of this is, I think it's roughly 1.5 degrees, 1 to 1.5 degrees. So that would be one where you could potentially fit both of them in the telescope, in the eyepiece together, the planet and the open cluster. And the big event that hopefully everyone is aware of is the night of December 7th. And on that night, both Mars and the moon will be at opposition. And that also means that the moon is going to occult Mars. And for Toronto, the event will run from, let's run this back a little bit, from about 10:30 p.m. to 11:18 p.m. In in Vancouver, it's about 7 p.m. to 7:52. In Calgary from 8 to 9 p.m. and then in Halifax from about 12:22 a.m. to 12:30 a.m. So those are things you want to keep an eye out for in your calendar in terms of Mars. All right.
We had
any questions on any of that before I proceed?
Yeah, we had a question which Blake answered, but I'm just going to repeat it. What sort of aperture is minimum for Mars satellites? And Blake said, Mars moons are at magnitude 12.5 and 13.6, so you need around an 8-inch scope or larger. But what you found as well, Chris?
Yeah, or larger is the or larger is the important part there.
So quite big scope. It's definitely not like the Galilean moons where you can see them. Almost.
No, I think I've seen them. I believe I've caught glimpses of them in my 12-inch Dobsonian. At the Carr Observatory, the Toronto Centre's Carr Observatory, we've seen them in that 16-inch telescope. So yeah, better to have a friend with a bigger telescope or a place that you can get a look through.
This is the time you convince your RASC Center members to all meet in a park, and the person with the biggest scope needs to come.
Yeah, exactly. All right. Anything else about Mars before we proceed?
Any questions? Okay. I think we're good.
All right, let's go into the NGC/IC catalogs topic. So autumn is the perfect time of the year to highlight the NGC, which is the new general catalog list of deep sky objects, and then the supplementary catalog, which is called the index catalog, or IC. And you'll see those terms NGC and IC in Stellarium or other astronomy apps that you might use, or star atlases. Because the originators of those lists were really taking it back to William Herschel, the astronomer William Herschel, and his sister Caroline, who started by sweeping the night sky and documenting the positions and features or characteristics of many of these deep sky objects. And I'll give you some history on that here in a minute. And they actually began that process in the autumn, during the autumn time of the year. So that's really great. Also, we're going to be jumping into talking about Alan Dyer's list of the finest NGC objects, which are listed in the RASC Observer's Handbook. And over the next number of weeks and months, we'll take you through viewing those objects and giving you some suggestions for how to find them and some characteristics to look out for. And Alan also listed his finest NGC list starting with the autumn objects, somewhere around right ascension 21 hours and 5 minutes, in that range. So if you're interested in some history about these folks, I can highly recommend this book by Mark Bratton. He's a Canadian, called The Complete Guide to the Herschel Objects. Most of this book is taken up by descriptions of the various objects in the catalog, but there's a terrific section at the beginning of the book, which is all about the history of the Herschels and how they went about mapping all of these objects. Also, the Cambridge Press, Cambridge Atlas of the Herschel objects is another great resource for that as well. All right, so kind of setting the stage, let's sort of wind the clock back and think about the timeline of things. So we have Galileo adopting the spyglass or the small optical telescope to view celestial objects back in 1610. And within a few decades of that, we have Isaac Newton coming up with a better approach. And he came up with the first reflector concept of the reflector telescope, which is mainly designed to compensate for the poor glass in the spyglass and the chromatic aberration, which sort of, gave you the color separation in Galileo's style of a telescope. So the Newtonian reflector helped solve a lot of that. He was using speculum, a certain kind of metal alloy called speculum, to produce that focused image. And then, of course, you've got the sort of 90-degree secondary mirror sending the light ray out the side of the Dobsonian telescopes that we use today, sort of the Newtonian telescope designs that we use today. Around 1721, English astronomer John Hadley altered Newton's spherical primary mirror and made it into a parabolic primary mirror. That improved the optics even more. And then that led to Charles Messier's era, where everybody had access to better quality telescopes. And so during sort of the 1750s, Messier was, of course, hunting for comets, but encountering all of these terrific deep sky objects in the sky that were visible from his latitude near Paris, France. And so his list sort of came out in the first edition in 1774, and then he finished his final sort of compendium in April of 1782. And by that time in history, telescopes were becoming pretty readily available to anybody that, had some extra money and wanted to be able to buy one and get into astronomical observations. They also had darker skies than we do, which is great. So along came this gentleman called Friedrich Wilhelm Herschel, who later became known as Sir William Herschel. He was born in Germany in 1738. He was a very skilled or talented musician. And at some point, his father arranged to have him leave sort of the war-torn region where he was from and emigrate to England, settled in eventually a place called Bath, England. His sister Caroline joined him as well in 1772. And the house that they shared on New King Street in Bath is now the Herschel Museum of Astronomy. If anybody's been there, that'd be kind of neat to hear about that. So arguably, Herschel's among the greatest observational astronomers of all time. He really devoted, years of his life to viewing the heavens and documenting what he saw for us to bring on today. So let's look at some pictures. Open up this hyperlink here, so we can see who we're talking about. Here we go. So there's William, and his sister also deserves a lot of credit, Caroline. So Caroline not only was an observer on her own right, discovered a number of comets, and approximately 14 deep sky objects were attributed to her. She also assisted with telescope making and taking all the notes and tabulating all the observations that William was doing. So Herschel became interested in astronomy, in mathematics, lenses, and during some free time in 1773, he began to read up on astronomy. He rented some telescopes. He started buying the components to make his own telescopes. And between about 1774 spring and 1776, he started using one of the Newtonian style telescopes to peruse the best of the sky, which were by then published as Messier's list. So people had already by then realized that those objects in Messier's list were fun to look at. So people were starting to enjoy them. He realized that he needed something better, bigger and better, as we all do when we get into astronomy. So he built himself a 9-inch aperture f13.3 Newtonian reflector. So they used to call the telescopes by their focal length. So that would have been called a 10-foot, so-called 10-foot telescope. And then he built a 12-inch diameter, 20-foot telescope. Now remember that this is actually a telescope with a tube that's literally 10 feet long or 20 feet long, which makes using it really kind of interesting. On May 28, 1776, he did an experiment where he removed the secondary mirror from inside the telescope tube and instead put his eyepiece at the front end of the optical tube assembly and was able to see an image by putting basically his face in front of the front end of the telescope. And the benefit to that was that the mirrors were so poor that every reflection would throw away the light. They were so inefficient. But by removing one of the two mirrors in the telescope, he was able to recover some of the brightness of the images. So he started doing that routinely, looking down the length of the telescope tube. Eventually, he realized that if he were to mount the primary mirror at a bit of an angle, then he could bring the focal point to a position near the rim of the aperture of the open end of the telescope and not have to put his face sort of square into the telescope. So that they refer now that mode now to Herschelian mode observations. Here's actually a replica of his telescope, one of his early telescopes that he made. This is, I think, similar to the telescope that he used to discover Uranus. It's really, I'm not going to spend a lot of time on all of his discoveries. Initially, he was most interested in double stars, which Blake will be happy to hear about. And it was during his sort of survey of all the bright stars to catalog which ones were double or multiple that he discovered Uranus in the process of doing that. So that's sort of the style of telescope that he would have done to do that. Alt-azimuth mount, where you could swivel it in azimuth and then tilt it in altitude. So that discovery of Uranus actually opened the doors to him. He started meeting all kinds of important astronomers, including the Astronomer Royal Neville Maskelyne in 1782. He started then manufacturing and selling telescopes, so he became, really a celebrity in astronomy. And around that time in 1782, he began building his dream telescope of the day, and that was an 18.7-inch diameter or aperture 20-foot telescope. So that would be an f12.8 focal ratio, and it would be mounted on a high frame. So let's open up this, take a look. There you go. So imagine having to do your observing with your big dog, but do it like this instead. So he had to build a tall frame that he could use to raise and lower it in altitude. He would have to perch up by the front end of the telescope and do his observations that way. It was on casters set with helpers. You could swivel the telescope in azimuth, and apparently the views were amazing. And so this is the prime instrument that he began to use for his sweep of the deep sky. Now, this is what inspired him, was looking at all the Messiers. He wanted to really, have a more powerful tool to be able to really explore the deep sky. Now, as I mentioned, Caroline was already working away. She was interested in looking for comets. He had built her a much smaller telescope that she could just sit beside and look at the nighttime sky. And in the process of doing that, she actually discovered a number of deep sky objects. She actually found NGC 7009, the Saturn Nebula, in September of 1783. So September of 1783 is really the interesting time when things really got cooking, because at that point, the big 20-foot telescope was ready to start using, and Herschel began sweeping the night sky with it. And now after only 5 nights, he picked up a galaxy called NGC 7184. So he was actually using, and I can simulate it here and see if we can do this. Pick up NGC 1784. 7184. Okay. Now, here's an interesting thing. If you're using stellarium, you realize that not every deep sky object has a photo background for it. So what you can do is go down and enable the DSS, or the Digital Sky Survey button in stellarium. And if you click on that, it'll actually bring up an image of the object. So there it is. Now what I used is I did Stellarium to simulate Herschel's telescope. So I'm going to bring that up now. Select telescope, Herschel's 20-foot, and pick up an ocular around, let's see, around here. So this is roughly the field of view that he was using. So it was about 150, his was about 157 power, a true field of view of about 15 arc minutes. And so that would have been kind of the scene that he would have seen. Now, obviously the galaxy wouldn't have been quite that bright, but that's how we did it. And the way you would search the sky was that he would have the helpers moving the frame, and he would slew the telescope east by about 12 or 14 degrees worth of the horizon. And then he would note anytime that he saw anything in that field of view as he swept west, or as he swept east, he would climb down the ladder, go into his little office and write his observations. Then he would climb back up, continue the sweep, and go from there. That was extremely painstaking and slow. When he finished a sweep, he'd wind back, raise or lower the telescope by about 10 arc minutes, and then he would do it again. So he would do a number of sort of swaths of the sky, building up a little block of sky that he would cover. So that lasted 2 months. He did that for about 2 months. He did 41 sets of those sweeps, and he found only 6 clusters by doing that. It was just way too slow. So he came up with a better approach. And what he did is he decided to fix the telescope's azimuth and just sweep the telescope north and south by about 2 degrees of the sky. And then he would just wait for the sky to move west and then sweep north-south again. So he didn't have to have anybody moving him in azimuth. He could just manually move the telescope in altitude and let the sky itself rotate through his field of view. He recruited Caroline, took her off her passion for comets, and put her onto the duty of logging his observations so that he wouldn't have to climb down and write them out himself. So in that period of time, so in 2 months, they found another 103 deep sky objects. A month later, they found another 133 objects. And by the end of June 1784, they had logged a total of 445 new objects. He was more or less avoiding or omitting Messier's targets, but eventually the Messiers did get incorporated into the NGC catalog, as you'll see later. So by the time they got to the following spring, so from the autumn of 1783, and then around a year later, in April of 1785, they'd accumulated 1,000 brand new deep sky objects. And then he published that in a catalog of 1,000 nebulae and clusters of stars, published in April of 1786. By the time they got to 1802, so he actually got married, he had a son, took a lot of time away from the eyepiece, so his sort of later sets of observations came a little bit more slowly, but the last set of his objects that he picked up, completing his sweeps, was on September 30th of 1802. So he had done 1,112 sweeps of the sky over a span of 14 years, covered almost all of the sky visible from the United Kingdom, all the way up to about 82 degrees north declination. So he didn't do the celestial pole region. So the most northerly object that he picked was NGC 6251 in Ursa Minor, and the most southerly object he picked up was NGC 3621 in Hydra. So what was kind of interesting about that is that no one on Earth had instrumentation that could confirm his observations. So they kind of had to take his word for it, and people weren't able to really confirm his discoveries until his son started doing this, going through them again a few decades later. So just to summarize where we ended up then, he published the first 1,000 of objects in 1786. He did a second 1,000 in 1789, and then the last 500 were released in 1802. Now, he arranged the objects by a class system. So let me just open up. Let's just do this and open this up. I'll show you the picture of his classification system. Now, he was using the word nebula or nebulae. And of course, in those days, nebulae was just anything fuzzy. So anything that was obviously not stellar. So you can see the first 5 classes here: bright nebulae, faint nebulae, very faint, planetary nebulae, and very large nebulae are all kind of fuzzy objects. And then you get into star clusters. So that obviously had stellar components that you could resolve in the big telescope. So very compressed star clusters of small and large stars, and then coarsely scattered clusters of stars. The brackets indicate the number of objects in each class. So he actually found almost 2,000 of his 2,500 ultimate objects consisted of faint and very faint nebulae. But remember that that includes galaxies. So galaxies looked fuzzy to him. And so what he was calling nebulae would included true nebulas, but also galaxies. So a lot of these big numbers you're seeing here represent the deep, rich galaxies that we see, especially in the springtime sky. So the way he was actually describing or tabulating his instruments is that he was using the class and then a numeral. So he had a Roman numeral for the class and then a regular numeral for the object. And he was just listing them in order that he found them. So the first object that he discovered was the planetary nebula object H4-1, and that's NGC 7009. So let's look at NGC 7009. We're going to actually come back to that in a little bit. NGC 7009 is in Aquarius. Here we go. And this is a planetary nebula. So that's why it was listed as his class 4. I won't go into all the other ones that he found first, but it's fun to look through what his 1-1, 2-1, and so on.
Chris, do you know when the first time, well, like Messier found galaxies, but when we kind of realized that they weren't nebulae?
So it didn't take long before, let's see, I'm coming back to, when did Dreyer do his thing here? Yeah. So by the end of the 1800s, people were actually starting to be able to take photographs of the nighttime sky. So I don't off the top of my head remember when the first true galaxy, I guess, obviously when Hubble realized that Andromeda Nebula was a galaxy, that was sort of kicked off the major realization that a lot of these objects were galaxies.
So it was still like when Herschel and Messier were all doing their observing, it made sense that they wouldn't be able to differentiate because there wasn't like
it actually, if you go into Bratton's book and a few other places, Herschel did at some point try to start to rationalize what he was seeing and the various types of objects and where they were, and are devising some theories about what was going on, what these objects were. So it's kind of fun to learn about that. I'll leave that for folks to look at.
Exercise to the reader.
Yeah. So his original list had 2,511 objects in it. Around 1990, Father Lucien Kemble, who's a famous or well-known rascal, Canadian rascal, he actually put together a digital file of Herschel's objects. He actually winnowed down a number of duplications and errors, things like that, and came up with 2,478 files in a digital list. My research seems to suggest that list has been lost, but I wonder if someone like Randall Rosenfeld might know of a copy of that existing somewhere. So that's be fun to find out. Just kind of to finish the Herschel story a little bit. So William Herschel was knighted in 1816. He founded what later became the British Royal Astronomical Society in 1820. He died at the ripe old age of 83 in 1822. In the meantime, his sister, as I said, discovered about 14 deep sky objects of her own between quite a short time, between February 17th and May of 1784. And then she discovered one more in the summer of 1787, mainly using a 4-inch reflector. That was her telescope that she used. She left England to go back home to Germany in her later years. She died in 1848. And you could put the link to that really nice article in Sky and Telescope by Bob King, all about his efforts to view all of Caroline's discoveries. That's kind of a neat story in there. Now, obviously, astronomy was picking up steam around the world, and people were interested in, you know, the limelight or getting credit for making some more of these discoveries in the sky. So one of the untapped sources of that was the southern hemisphere, the southern sky, the southern celestial sphere. So people started to produce or to prepare for expeditions to the southern hemisphere to view those skies. So Edmund Halley, he went to South Africa in 1676. Lacaille, who contributed to Messier's list as one of his contemporaries, he went to South Africa around 1751-52. James Dunlop went to Australia in 1826. And eventually, William's son, John Herschel, decided to take up his father's mantle, and he actually took his father's fantastic 20-inch or 20-foot telescope with him on a voyage down to Cape Town, South Africa, and arriving there in January of 1834. He spent the next 4 years mapping the southern sky and also confirming, you know, some of the other objects that were in the more northerly catalog that William had already put together. So in 1864, John returned back to England and compiled everything and published it as the General Catalogue of Nebulae and Clusters of Stars, containing 5,079 entries. So that was double what his father and Caroline had put together originally. So now we enter the era where we get to the NGC, the new General Catalog. So as Herschel had been interested in viewing Messier's objects, now amateur astronomers were interested in viewing Herschel's objects in his published catalogs. So in 1878, English astronomer John Louis Emile Dreyer, or J.L. Dreyer, as you might see him written out, he published a supplement to Herschel's catalogs. And then in 1886, he suggested building, expanding on it or building a supplement to it. But the Royal Astronomical Society instead asked him to compile sort of one, instead of having an add-on or a tack-on, they said, why don't you produce a comprehensive index as well, listing instead. So that's when he produced the publication called the New General Catalog, or NGC, in 1888. And that's the basic or forerunner or foundation of the NGC, words that we use today. So in 1895, he did end up publishing a supplement to it, because by then more and more objects were being discovered through photography and better telescopes. So that's when he produced the Index Catalog of Nebulae and Clusters of Stars, otherwise known as the IC. So when you go into Stellarium and go into the F4 tab, hit the DSO tabs, you're going to see the M objects for Messier, the C objects for Caldwell, which we've talked about in a previous session. And then you've got the NGC class and the IC class. So altogether, you're looking at about, let's see, total of 5,386 in the IC, and I don't know if I wrote the number down for the NGC, but it's around 5,000 as well. You've got about 10,000 celestial object or deep sky objects in this catalog. Now, the corrections were made to that. So over the years, the various catalogs have been updated, corrected, improved. So Dreyer himself produced a revised or improved version in 1912. And then the revised NGC, or New General Catalog, came out. It was compiled by Jack Salentik and William Tift in the early 70s and published in 1973 as an update to the NGC. Sky and Telescope backed a version by Roger Sinnott called the NGC 2000 list. And that was produced using the J2000 sky coordinates. And it also corrected some errors that were produced over the years. In 2017, something called the NGC/IC project was completed. And it was just, they were basically, their goal was to identify all the correct objects, remove duplicates, fix the errors. One of the approaches that they used was to use the Palomar plates, the sky survey plates that we've talked about before, and see if they could identify all the various objects on those plates. And doing that, they actually eliminated a number of objects, but then visual observers went back later and rediscovered the ones that just didn't happen to be visible on those plates. So things have been sort of added and subtracted over the years. But Samantha can put in the link, the link that I put there from, let's see, Steve Gottlieb has a website where he has actually kind of made a repository for the NGCIC project database. And I did want to mention something about some of these web resources. So stop sharing for a second here. If you've created a resource, a web resource, like Father Kemble did, or some of these other gentlemen have done over time, if you're thinking of retiring that website, why don't you pass it off to somebody? See if you can find an astronomy group, maybe the RASC or an American, or depending on where you are. See if you can find somebody that will be will kind of adopt your project to keep it alive. And that could be true of you know, an observing log set, or a special compilation that you put together, or photographs, gallery, things like that. So just putting that out there as a bit of an aside. So for those of us that are, you know, a lot of us in RASC are kind of older and slowing down. So, but a lot of us have put a lot of work in over the years. So think about that, you know, archiving it in some way. See if you can find somebody that you can pass the torch to. Let's see if there's any final things I want to say about this. So the NGCIC project ended up with 9,860 total objects in it. And there's a revised version. So basically, you know, that's what you've got available to medium, large, you know, amateur telescopes. No end of things to look at. And there are people who have actually made it a life's work of viewing every single one of them. So that's kind of neat. So there you go, Samantha. You ready? Get on that.
I need to buy a new telescope. I don't think my telescope's big enough for this. This is definitely a step up from Messier, but it's interesting. Like things like the Veil Nebula, everybody kind of knows it, but they don't realize it's not a Messier object, but it's so popular. So definitely interesting to hear the background.
Yeah, yeah. So the Messiers did end up as NGC objects. So obviously there was no reason to leave them out of the list. If you're producing a master list of all the various objects, obviously you're going to bring those in. But that does bring us to beyond Messier, what to look at after you've done them. Yeah, go ahead.
Oh, sorry. We had a question quickly about Herschel. Did astronomers in the 17th century and the early 1800s really understand what they were finding, especially as regards to their size?
As regards to which?
Like the size of what they were looking at, what they were even looking at?
No.
It's interesting to even just found them, you know. I guess that's where Messier started, where these things in the sky that don't look like individual stars, but
well, Messier himself, I don't think was worrying too much about what they were. He may have spent some time thinking about that, but mostly he had a mission and he was trying to find the comets. William Herschel definitely did give it some thought, and it is fun to read up on what some of his early theories were. Hubble was, the Harvard Observatory people, the ladies at the Harvard Observatory and the folks there, they were making it their mission to map the sky and to catalog the stars and their spectra. And that's where the Cepheid variable stars were discovered, and the luminosity distance relationship that come with those. And so that all spun into finding those Cepheid variables in other deep sky objects, including globular clusters around the Milky Way, but also Cepheid variables in other objects like the Andromeda galaxy. Mm-hmm. And that's when the penny dropped, that the number, when they crunched the numbers and figured out how far away they must be, they're not in our Milky Way. they're another galaxy altogether, and it just bloomed from there.
Just to be back in what they were thinking back then. Seeing, just even looking at Andromeda now, I guess they didn't have as much light pollution, but it just looks like a smudge in the sky. They're small telescopes. So,
well, that's another fun part about outreach is when you know something about the object you're showing people, it makes a much more impactful impression on them, right? You know, when we're at the David Dunlap Observatory and we're showing somebody, it's albeit a very small field of view through the giant telescope. And sometimes it's a pair of double stars or something like that, a binary star system. You know, not everybody's super impressed, but you start explaining what they're actually seeing and what they just appreciate it much more and make it more memorable. Yeah. Cool.
Thank you. We had somebody in the chat said, very thank you for your thoroughness of exploration and going through the history. They really appreciated it. So
it was the condensed version. It's fun. Okay. So now we'll get to the main event, one of the main events, and that is the RASC's finest NGC list. So a number of people over the years have worked out that there's a lot more to look at than just the Messier objects. There's 110 out of 10,000. I mean, come on. But obviously the Messier ones that predominantly are bright, fairly big and bright and easy to see. But people like Sir Patrick Moore in England, he said, well, hold up, you know, Messier only really looked at the northern hemisphere sky, and he maybe overlooked a number of things that I think are worth a view. And so he created his own list of 110 objects that he numbered them from the North Celestial Pole all the way to the South Pole Celestial Pole. So you actually can't see all the Caldwells unless you take a trip to the tropics or the Southern Hemisphere. So that's kind of fun, a fun life bucket list sort of thing to do. And then Alan Dyer, and you know, many rascals who are avid visual observers. So Alan Dyer being one of them, our friend Alan Dyer, he's former guest on Insider's Guide. A number of years ago, he proposed a list of deep sky objects that would be fine alternatives to the Messiers. So you can put the link into the RASC hosted pages that the observer.
I will also shout out as everybody is getting their observer's handbook, but every single year we have this list as well in the back of the observer's handbook. I just
give them the page.
Give them the page. I will give them the exact page. I just flipped to it and now I lost it. Okay. Fire stars, star clusters, 316 and 317, 316 to 318. Is the pages, and it's listed by season, and I will give the link as well.
Yeah. So to quote the blurb or their little write-up on the rasc.ca website, the finest NGC list compiled by Alan Dyer and published in the annual handbook complements the Messier catalog as there is no overlap. So these would be brand new objects, 110 objects, and 110 just because there are 110 Messiers, so 110 new things. Many fine deep sky treasures and some mildly challenging objects. So don't be put off by the mildly challenging phrase there. If you listed all the Messiers and the finest NGCs and sort of sorted them by visual magnitude, there's lots of overlap. So there's plenty of Messiers that are fainter than Alan's picks. And so it's you know, don't assume that it's going to be too hard to see them, because that's not true. There are some that are even bright enough for telescopes, for binoculars. Another neat thing is that we do recommend that if you want to do the observing programs at RASC, that you start with the beginner programs like the Explore the Universe, and then you go into the Messier objects. And by the time you finish that, you'll actually have trained yourself to be an observer pretty well. Part of the trick is to learn how to see dim objects. And so you get to develop that skill as you're doing the Messiers. So you'll be all set to go for the finest NGC when you're done the Messiers. Why not? And you could even do them at the same time, for goodness sakes. If you've got that patch of the sky, maybe think about doing that. So flip from the Messier pages in the handbook over to the finest NGC.
No one's stopping you from doing it out of order.
Do them at the same time.
Just keep your observations. Like we have just a hint about observations is when we were doing the Explore the Moon program, the person doing with it missed one of the craters just before they're about to hand in their observations. And John Reed, and he went back and looked into his old notes from like 15 years ago and found he had recorded that observation and included that and got the certificate from there. So there's no timeline to finish this. If you are just lucky enough to see the Veil Nebula one night, or I don't know if that's on the list, I'm just know it's NGC, or the Clown Face Nebula, record it down. And maybe years later you will have them all.
So here's a couple of other things. So the an 8-inch aperture telescope will have almost no problem seeing everything in the finest NGC. So especially if you've got dark skies. So if you've got dark skies, even a smaller telescope will be fine. You can use a 6-inch telescope if you've got beautiful rural dark moonless skies. That's not a problem. Typically, if you're kind of, suburban medium dark, then you'll want something a little bigger. So an 8-inch telescope would be great, or a 10-inch telescope would be great. Yeah, I said but a dozen objects are bright enough to see in binoculars and very small telescopes. And there are some that are a bit more challenging, mainly because they're relatively southerly in the sky. They don't climb very high for Canadians. So some of our viewers that are in more northerly towns and cities, you'll have some challenges, and you'll need to pick the best few nights of the year to get them when they're higher. The program is a solo, just like the Messier plan. It's a solo program. You want to do each individual. I mean, teams can do it, groups can do it, family members can do it. Each just has to do their own observations and their own log.
My father and I were working to explore the moon together. We'd both have our binoculars, and we'd be setting them up or looking back and forth and writing down. We made sure we had our own observations, but it's definitely a lot of fun to do it with other people.
You can do. I should have had my pin out, but I didn't get my pin out.
Oh wait, do I have them? I have them.
You can do it for go-to or non-go-to. So I reckon, it's nice to do the non-go-to and really learn if you're not in a rush. So, and I'm going to show you how to find some of these objects as we go. You got one? There it is.
That's the NGC pin.
There's the NGC pin.
Sorry,
Cool.
It's a little bit smaller than the Explore EU one and the Moon one, but it's just as important. Honestly, they're really cool. And thanks to the observing committee for all they do for these programs.
Shout out to Blake, current chair.
Shout out to Blake, the chat. I just had a question in the chat about the beginner observing programs. I sent a link to Explore. It's called Explore the Universe. It's the same guide you get in your package. As well as there was a question about where to buy telescopes and telescopes guides. We also have previous episodes of Insider's Guide about that, as well as we're going to be talking about gift guides next session. So that might be a nice place to hear from a bunch of different perspectives what we might be wanting for Christmas, from the beginner to the expert that is Chris. So
yeah, we'll come back in 2 weeks and we'll probably devote at least a few minutes of that program to some recommended beginner models of telescopes and kind of the prices that you need to pay. So that's great. Good idea. All right, so let's get into, I'll cover for a few minutes some tips for getting into the finest NGC program, and then we'll actually showcase the first half dozen to get you started this time of year.
Before we start that, while Chris is pulling things up, we don't have a name for this yet. We had Messy Minutes because, M&M, but we have Finest Minutes as a placeholder. But if you can come up or give any better suggestions of what should we call this section, what we should call the website, we would really appreciate it. Throw it in the chat while Chris is talking if you think of any. I have not made the guides yet, so we will be adding, we can change them quite easily.
Yeah, we'll do something similar to what we did for the Messier objects. Let me just bring up the list here. Okay. So in terms of, I'll share my screen again. Here we go. Here we go. Share screen. We'll come back to this in a second. So there are 22 in the whole list of 110. There are 22 autumn objects, 16 winter objects, 51 spring, and 21 summer. So the reason that the spring is so heavily loaded with both the Messier's and the Finest NGC program is because the spring sky is so rich with galaxies. So that's generally the case in all of these programs. But what's nice is that the autumn and winter, it's a limited number of them so that you can actually get rolling. And then by the time you get to the spring, you'll be ready to roll into spring and tackle more of the objects. What's great is that even though we're about to transition into December, you can still pick up virtually all of the autumn and Finest NGC objects. So I'm just going to highlight where they are here, and then we'll dip in here. Let's see. Here we go. So what you're seeing here is all these blue circles are just the autumn set, the 22 autumn set. And by the way, Blake and I worked together to produce Stellarium bookmark or observing list files for each of the seasons of the Finest NGC. And if you navigate over to rascto.ca or Google observing lists,
it's all on they're also on the Finest NGC, that observing page on the regular RASC website.
Yeah.
Can you quickly show us how to add an observing list again?
I can.
Just before, because I know you've told us me a million times, but I have a short memory.
Yeah. So you go down to the toolbar and you should see what looks like I don't know, like a blue ribbon thing. It's a bookmark. I guess it's a bookmark. So you click on that bookmark to brighten it up, and it'll open up a dialog box, which might be empty if you've never done it before. And then if you look to the bottom of this box, you can see that there are some buttons here, and one of them is New List. If you click New List, then you can actually click on objects and build your own list. So if you can click and add objects as you go, and you can add or remove them. And then you can import them and export them, and then you can save and close when you're done and give them a name as well. And you can also have it store the celestial coordinate. And if you even wanted it limited to just the date you're looking, you could even set the date, location, landscape, and field of view. But I normally would leave these off. But if you want to import from one of the repositories, then what you do is you import the list button. And you would have had to previously download these. So you could go in and find a link
in the chat to where you can download them.
So for example, if I go into Finest NGC winter here and say open, then you can see those objects get put in the list, and you give it a name and a title, and you can click save and close, which I'm not going to do for the moment, but that's what you do, save and close. Then this box will close up. And then back to the big box, there's a drop-down menu, and you'll see the ones you've added show up in this list. So at the moment, I've picked up my Finest NGC autumn targets.
Perfect. Blake also just highlighted that the toolbar button down there is not by default, but Alt-B or Option-B on Mac is where you'll get it from.
Yeah, if you want to have that button, you need to go into your configuration window. I believe it's under extras, maybe. Under extras tab, you want to, I think it's this one, observing list. You need a check mark in the observing lists box in here. And you may need to restart. You may need to restart Stellarium when you do that. Okay, so all of the autumn objects, we're not too late to still see all of the autumn objects because it gets dark so early. So right now, I think today, the end of astronomical twilight, when the sky is fully dark, arrives around 6:30 p.m., believe it or not. So at that time, which I'm showing here right now, you can see, let's bring up the meridian. You can see that only one of the autumn objects is already past the meridian, is starting to sink. That's the NGC 7009. Wait, that's the Saturn Nebula. That's the one that Caroline Herschel discovered first and became also one of William's first objects as well. So that's cool that we can actually recreate history by by picking that one up. So all of them, all the autumn ones can be gotten right after dinner, early evening. The winter ones come into view towards midnight. And if you wanted to pull an all-nighter, you could start picking up some of the springtime ones as well. All but 3 of the finest NGC are observable from midnight to 1 a.m. in late November. All but 3 of the winter objects. So you can stay up till about 1 a.m. and get virtually all of autumn, all of winter done. Although it takes a longer time than that. When I'm doing these programs and I'm searching manually, I typically get 6 to 10 of the objects found, observed, and written up in a single night. So don't panic if you're going.
So I would probably get 1 or 2 maybe.
Yeah, but your rate will increase as you get more practiced at star hopping and things like that. But yeah, I must say that a wide field telescope is really handy or helpful. So any telescope with a focal ratio in the f5, f6, f7, which is giving you a fairly healthy field of view, because one of the main functions of the program is to find the objects manually. And to find an object, it's nicer to have a bigger search field or a larger field of view to do that with. So I currently use a f5 reflector, which is a more expensive telescope, but it really makes it easier. So if you've got one of those, even the 6-inch Dobsonians or 8-inch Dobsonians, I think those are around f6, something like that in that range. They give you a nice, pretty healthy patch of sky to search in. I like to use a Telrad that gives me the rings, the bullseye rings, or a Rigel Quick Finder is another kind of non-magnifying finder scope. Or, you can have one of the erect field image finder as well to help you get yourself aimed up. I like a long focal length eyepiece. So if you don't already own a longer focal length eyepiece, say more than 25 or 26 millimeter focal length, like a 30 or even a 40 in some cases, those are great to have if you're setting out to search for things in the sky, manually, because those will give you a nice generous field of view, like 1.5 degrees or maybe even upwards of 2 degrees, depending on the telescope. Samantha can put the link to the telescope eyepiece or telescope calculator online tool that I really like to use in there. It's really nice. You can put in imperial units or metric units, and it calculates everything you can see to that particular eyepiece and telescope. I like to use apps, mobile apps when I'm doing these searches. Star atlases are fine, but the star atlas isn't always going to match up what your eyepiece shows you, because if you're using a refractor with a star diagonal, or if you're using a Schmidt-Cassegrain telescope with a star diagonal, you're going to get a mirror imaged view that will be flipped mirrored image of the paper atlas. Whereas if you're using a Stellarium Mobile or a Sky Safari, there are buttons in there, and especially in the Plus versions and Pro versions, that let you temporarily flip both in horizontal and vertical to match your view. Now, if you do have a Newtonian reflector in a Dobsonian style telescope, you can take your star atlas and just rotate it 180 degrees, and then it matches your eyepiece. So that's a neat trick. Let's see. You want to ideally wait until the fainter objects are at their highest point in the sky, which means you're looking at them through the least amount of interfering atmosphere. So that's the green line here. This is the meridian. So when objects are near the green line, they're at their highest point of the sky, and that's your best bet if the object is a fainter object. Also, if you're looking at the list you're about to tackle, see which ones are brighter, see which ones are fainter. If the objects are, say, a brighter star cluster, then you can maybe tolerate some moonlight to see that object, or you can maybe doesn't need to be quite as high in the sky, or the sky doesn't need to be quite as dark. But if you do have some more faint objects on there, you want to reserve the best nights for tackling those when the sky conditions are better. Do try to get your eyes dark adapted. Some people like to wear an eye patch over the eye that they're going to be observing. That's a neat thing you can do. Obviously, avoid your bright lights off your smartphone or your tablet if you are using those devices. I generally, I mute the notifications so I don't get a bright text that's going to come up with white light if I have my tablet beside me. And if you've got a telescope that needs collimation, that's a good thing to do a star test to see if your collimation is accurate, because the better your optics, the more easily you're going to find it and view the things. Also check your weather. You want to be looking for nights where the transparency is nice and high and the seeing is nice and stable. So for me, I always glance up and look at how much the stars are twinkling. That tells me what the seeing is likely to be like. Any questions in any of that part? No, we're good.
I think we're good.
Right.
There is a question about tablets. Honestly, tablets in general do not like cold temperatures because of the battery. My best iPhones in particular we were talking about, I find are worse than Androids, but in general, your best bet is to probably make sure the battery just kind of like runs out. So probably have a separate battery for that. I don't know how you deal with it in cold weather.
Well, I usually keep, if I'm using my phone, then I keep it tucked into a pocket when I'm not using it. Or if you're using a tablet and you could keep it charged, if you have a battery pack and you keep it charging, that might help.
Hand warmers underneath.
Sure, if you want in the winter. The other thing is that if you've got red film, it's a great help to put a red film over the entire surface, a display, if you're planning to leave those out where your eyes can see them.
We have one more question. Is there a good site or like tutorial you have to how to colorize a scope, or how would somebody go about to learn how to do that?
If you do a web search for, Newtonian reflector collimation, there are lots of sites. I don't know if Blake is on the line, if he has a favorite site. I don't have one readily at hand, but I can have one ready for our next meeting. Yeah, or find a rascal that's good at it.
Yeah, this is another good way to connect with your local centers. They give you this advice. I'll be honest, I just use a laser in the eyepiece to make my life easier, but a specific laser made for collimation.
Yeah.
I will let's move on. We got a lot.
Okay, so now let's tackle my first recommended set of targets to choose from as we launch our trip through the finest NGCs. It just happens that we're going to go through 1, 2, 3, 4, 5, 6, and 7. So thank you, Alan Dyer, for numbering them in such a way that that's the best approach. So if you've got sorry?
I was going to add in the chart, we're going to have FNGC. That means finest finest NGCs. That's the number we have assigned in our list, which took me a little bit to figure out when you handed me your observing notes, but makes sense now.
Sorry about that. Okay, so when you're in your observing list in Stellarium here, one of the neat things that you can do now that you couldn't do before, and by the way, this is now as of version 1.0 or 1.1, a major release that came out last few weeks or month, is that you can actually sort by any of these categories. And you can even sort by brightness if you want to, magnitude, visual magnitude, or which constellation it's in. I'm going to actually sort by object name because this particular list has the finest NGC numbers first. So we've got a column ordered by finest NGC number. We've also got the NGC or IC numbers here, the constellation, the type, so PN for planetary nebula, SG for spiral galaxy, EN for emission nebula, OC for open cluster, EG for elliptical galaxy, and I think, emission nebula, let's see, I think those are all the categories.
And if you
LG.
don't remember these, like I do not remember them, there is a code at the bottom of every single observing sheet that is provided by the RASC.
All right. Okay. So first up, I'm gonna go with NGC number 1, or finest NGC number 1, which is NGC 7009, which is the Saturn Nebula, which is the one we've already talked about, that Caroline found and which William found. It is about magnitude 8.3, 8.3, depending on the source you look at. It's tiny. It's only 41 by 35 arc seconds. So it's the size of a planet as opposed to some of the bigger objects that we look at. It's a terrific object. It's really interesting. It's Herschel code H4-1. So it's the first of his planetary nebulae objects. It just happens that this year only, the Saturn Nebula is beside Saturn in the sky. So that's kind of fun for November of 2022. So you've got your planet Saturn and your Saturn Nebula. It's 1.3 degrees west-southwest of the magnitude star, 4.5 star Aldebaran 2, which is this star right here. Or you can get yourself in the neighborhood by looking midway between the star 3 Aquarii. So where we go? Yeah. So we've got a few other stars in here you can look at. So you've got the stars of Aquarius, the foot of Aquarius, and you've got the tail of Capricornus, the sea goat in here. So it's about midway between 3 Aquarii and Iota Cap. So here's Iota Cap down here. And let's just put this through here. There we go. I'll just actually mark, I'm going to highlight these so we can have it highlighted. There we go. So we're drawing a line. So basically, if you go up to this star K Aquarii, or Kappa Aquarii, or 3 Aquarii, if you can see Iota and if you can see Kappa, then the Saturn Nebula is right between them. But if you can find Aldebaran 2 or is that New Aquarii, then you can also do it that way. And the telescope, let's just go into the regular Dobsonian 6-inch telescope that we usually look at. So at low magnification, so using a lower magnification eyepiece, you might even be able to fill the field of view. Let's just put the 26mm Plossl in here. It's pretty much in the same field of view as the Aldebaran 2 star, okay? But you've got to account for the direction, so it sits to the west. You want to use more magnification on this object because it is so tiny. So I recommend 150x to about 300x. If your sky conditions will let you use that much power. When you're looking at it, you want to look for its interesting shape. Whoops, I'm on the wrong thing. Let's go back to, there we go. You want to look for you should be able to see its non-round shape, even if your telescope isn't that big. And you might be able to see the central star, the white dwarf star in the center of the object. And it benefits from using averted vision, and it will get brighter or enhanced if you've got an oxygen 3 or a UHC filter. So that's a good one to use. All right, let's go on to the number 2 here. So number 2 is the Helix Nebula. By the way, Herschel missed the Helix Nebula for some reason, even though it is huge. So the Helix Nebula is really an amazing object. But it's faint. It's big, but it's quite faint. It's about 650 light years away. It's one of the closest planetary nebulas to our solar system. This year, the asteroid Vesta is in the same neighborhood. Here's Vesta, if you're interested in doing a 2-for-1. It's located within the triangle formed by the bright star Fomalhaut. Okay, let me get this right here. Fomalhaut and Scat, which is a relatively bright star, and Deneb Algeti. So if you sort of find these 3 brighter stars, then you're in the neighborhood. What I did is I star hopped from Scat. So from Scat, I went down to the G1, which is actually G1 and G2. So these ones are pretty easy to find, G1 and G2 Aquarii. Then I went to U, Upsilon Aquarii, and then I was in the neighborhood from there. And if you go into the, there's Upsilon here just out of the field of view. So you could actually pretty much get them to share the field of view. So by the time you put Upsilon on the eastern side of your field of view, you should be able to see the helix if your sky is dark. So you want to keep your magnification down for this one. So 50 power, something like that. And again, averted vision, oxygen 3, UHC. Note its shape if you see any out of roundness, see any central star, look for the field stars around it. It's a cool object, really, really neat. And again, these first two that I mentioned, they're ones that you want to get right after dinner, so 6:30 in the evening before they start descending into the western sky. Okay. The next one, number 3, is the Deerlick group, and it was written up, and I wrote it up in Sky News recently. Deerlick group. This one's up in Pegasus. So the Deerlick group is a fantastic, relatively good sized spiral galaxy. It's brightened by its oblique orientation, so it's not quite edge on to Earth, but its brightness is enhanced by its narrowed shape. It's Herschel HI-53. Its name comes from the place where it was sort of discovered by modern amateur astronomers at the Deerlick Gap. So they sort of coined that name for it. That's why it's got that funny name to it. It's located 4.5 degrees north-northwest of the magnitude 2.9 star Matar. So where's Matar? Here's Matar, just one of the legs of Pegasus. What I do is I double the line from Saddlebari. You can see these two stars with your unaided eyes. So you can just double the line up through the sort of knee of the horse. Almost double, not quite double, but run up through there. And you can also look for, there are a couple of stars in the area. So you can look for a couple of these stars you've gone, then you know you've gone too far. So in this object, you want to look for, whoops, go back to it here. Again, this is at pretty low magnification. This is only at 30x. So you can increase the magnification a little bit. You want to notice its shape, its orientation, how its core and halo look. If you've got really a big telescope and dark skies, you can look for the fleas. So the deer fleas are these little galaxies in the far distant background, just off to the east of the main galaxy. And also in the same neighborhood, you've got Stephan's quintet, this little grouping of galaxies nearby as a bonus. The rest of, so that one would be good before 10 p.m. local time. The rest of the objects you can really take your time with, so all evening long. Next one I've got is number 4. And that's swinging around and looking sort of north. So there's Polaris. You're going to look between Cepheus and Cassiopeia for the Bubble Nebula. So the Bubble Nebula is faint. It's a hydrogen-2 emission nebula. It's Herschel class 4-52, located between Cepheus and Cassiopeia. And it's right near Messier 52. This is Messier 52 down here. I don't have the Messiers listed. I'll bring those on so you can see those.
This one is one you often see in astrophotography. It's a very nice astrophotography target.
Yeah.
It's one of my favorites.
So what I do to find that one is, if you've already found M52 in the past, you'll be kind of in the neighborhood already. What I do is I draw the line from Shedar to Kaf. So if you can take the top of the W of Cassiopeia from Shedar to Kaf, and a bit more than twice that distance in that direction will get you in the neighborhood, especially if you're using a nice 1.5 degree field of view eyepiece or something. You'll be able to find it. Now it is faint, so it's going to be a bit trickier to see this one. So you want to look for any structure or shape that you can make out. You can look for the central stars in the middle of it. There are a little clump of stars in the center of it. It's got some field stars. You want to use averted vision again, and again, your O3 filters or your UHC filters would help brighten that one up. All right, number 5. In the same neighborhood. So number 5 is Caroline's Rose. So this is one of the objects that Caroline Herschel discovered in 1783. It joined the main list as Herschel Class 6-30. It's a huge, rich, open star cluster, very populous, very dense, but not very bright. It's pretty subtle. Some people, when they look at this, they detect arcs of stars that are reminiscent of rose petals. That's where the name Caroline's Rose comes from. You want to use low power, don't magnify it too much, and you want to use your averted vision. So again, here's the 26mm Plössl and the 6-inch telescope. It takes up, half the field of view. So it's a beautiful, beautiful object to look at. Again, you can estimate how many stars you see. You can sort of remark in any shape that might strike you. So that's a great thing to take note of. And that one, yeah, it's 30 arc minutes. So it's the same diameter as the full moon. All right, back to number 6. Here we go. Number 6 is in the same neighborhood. Now here's the Andromeda Galaxy M31. So bear that in mind if you know how to find the Andromeda Galaxy. We often use the deeper V of Cassiopeia as a pointer towards the Andromeda Galaxy. But in this case, you use the same technique, but stop halfway. And you'll be in the neighborhood of NGC 185. So NGC 185 is a good size dwarf spheroidal galaxy. It does seem that it's gravitationally bound to Messier 31, the Andromeda Galaxy. So it's also about 2 million light years away. It's a Herschel Class 2-707. And I look midway between the stars, Mu Andromedae and Calf. So you can do it this way as well. So make a vector and kind of make a line between those two stars and look about halfway between them. And that's also the same neighborhood that you'll find it there. When you're looking at it, and I'll just bring it up in the eyepiece view here, you want to look for the orientation of it, the shape of it, notice any stars around it, look at the characteristics of the core, the halo around that. Don't use a filter. You don't want to use a filter on galaxies. That darkens them. There's also another galaxy in the neighborhood, NGC 147, which I'll bring up here. So if you actually shift your field of view a little bit, you can have both of these galaxies in the same field, which is fun. 147 and 185. All right, our last one for today is number 7, and it's also in Cassiopeia. And Cassiopeia objects are really nice and easy to find because there's so many good signposts that you can use. So this is the Pac-Man Nebula, another fantastic imaging target, but it is visible in a telescope visually. It is faint, it is large, and it contains a neat little cluster inside of it called IC 1590. And it's not a Herschel object, but it is in the NGC catalog. And it's at the, it has the southwestern corner of an equilateral triangle formed by Shedar and Achard. And so you can see that you can make these 3 into a trio or a triangle of stars. So on November evenings, let's say we go a bit later in the, let's go to about 8:30 p.m., then the Pac-Man's going to be to the right of Shedar and Achard, those two stars. And you can even actually fit Achard in the same 1.5 degree field of view with the Pac-Man. Don't magnify it too much, so you want to use about 50x. So there's the view at 35x. You can see it's already pretty much filling the field of view. And averted vision helps a lot. It's got this nice dark lane that forms the mouth of the Pac-Man that actually gives it a bit more dramatic looks. You can actually look for that dark transition between that dark missing piece and the brighter nebulosity above it. And I found that the cluster in the center kind of reminded me of the Pac-Man's eye. If you've got an O3 oxygen 3 filter or a UHC filter, you can actually brighten up the nebula part. And yeah, so look at its overall shape, see if you can see its mouth, see if you can see its eye, and go from there. So that's it for today. So the sky is going to be fairly dark for the next 5 or 6 nights. So it'll be ideal for getting out there and looking at those objects.
I'm going to throw in the chat. As I said, we have a placeholder name if anybody thinks there's something interesting, but we have started a new web page where we will, similar to the Messier Minutes, because everyone said they found those guides helpful and having them all in one place. We will be creating a separate playlist for this stuff, as well as having guides for each week. I also have my assistant working on taking everything we learned about the Messier and put them all into one nice guide with general times of the year or seasons to look at instead of the exact dates that we have. So I will let you know when that is up. And yeah, thank you so much, Chris, for another awesome session.
I hope everybody's feeling finest.
Oh, we all enjoyed it. I learned a lot. So get out there
Fantastic.
and start viewing the night sky.
Yeah, let us know how you do and whether you have any questions. And we'll see you in 2 weeks where we're going to have a nice light and airy session on neat gifts and gadgets that people who are astronomers or love astronomers
Bring
might
some
be.
ideas to share with us of what you might want so we can talk about those as well. So
Fantastic.
thanks all.
Everybody,
Have a-
keep